So today we're going to be looking at a composition of functions. Now, there's a couple types of composition of functions. The first type is where we add, subtract, multiply, or divide them. The second type is where we insert one into the other. So what we're going to start with is we're going to start with the introductory type, where we basically just take one or more functions and we perform some sort of basic mathematical practice on them. So let's take a look at our four functions. I have f, which is defined as x squared, g, which is 5x, h, which is x plus 10, and j, which is 1/5 of x. And so let's go ahead and get started on a few of these operations. So on number one, I'm taking f plus g of x. Now what this means is I'm going to take both functions, because it is in function notation. I'm going to take the function called f and add it to the function called g. So what I'm going to do is I'm going to say, okay, let me define my f and my g. My f of x is equal to x squared, and my g, let's do my g in blue. G of x is defined as 5x. So if I take f plus g of x, quite literally what this is telling me to do is take f of x and add it to g of x, which means I'm going to replace my f of x with my x squared, and I'm going to add it to my g of x, which in this case is going to be 5x. Now, here I can't really do anything other than say, okay, that's it. If there were any terms to combine, I would do it. If there was anything that I could simplify or distribute, I would. But at this point, that's all that I can do before moving forward. So similarly, let's go ahead and check out number 3. This is saying g minus h of x. So the first thing I have to do is define my two functions. My g of x is my 5x. And let's do h of x in purple. H of x is x plus 10. So when I see something like g minus h of x, it's saying take g of x and subtract h of x. Now, unlike addition, one of the things that I am going to have to pay attention to is the fact that I have a subtraction sign out here. H is a binomial, which means that I'm going to have to take that negative sign and distribute to each one of these. But if you want to avoid that, let's go ahead and say minus, and let's just fill in what we know. So g of x is 5x, and h of x is going to be x plus 10. This sets things up a little easier to spot. I know that I'm going to be taking 5x, and I'm going to distribute that negative to both of these terms, which makes that minus x minus 10. I can then combine my 5x minus x into a 4x minus 10, and there we go. Perfect. Now, if we can add or subtract them, we can definitely multiply and divide them. So let's take a quick look at number 5. So we have f times g of x. What that means is we're going to take our f of x, and I'm going to multiply it times our g of x, which means I'm going to need to define f and g again. So if f is x squared and g is 5x, what we are going to do is we're going to say, okay, let's take x squared and multiply it times 5x. Now in this case, it's just one step. 5x times x squared is going to give us 5x cubed. And so that is defined as f times g of x. I can take those same two functions and divide. I can say, okay, f divided by g of x, that's quite literally telling us to take f of x and divide it by g of x into a rational function there. So if I have f of x, which is defined as x squared, and g of x, which is defined as 5x, we're going to say, okay, let's set up this expression. Plug in the x squared up top and the 5x on bottom. And what we notice is the first thing that happens is I have an x in the top and the bottom. I have one in the numerator and one in the denominator. And so I'm going to cancel at least one of those out, which is going to leave me with an x up top over 5. Now, I could circle this as my answer depending on the form you want. If you want it written in a standard form, you could say, well, this is equal to 1/5 of x. That would also be an acceptable answer. Perfect. And lastly, one of the things with function compositions that some people get uncomfortable with is I can take a function and multiply it by itself, add it to itself, subtract it from itself. Here I have j times j of x. So let's go ahead and define our j of x is going to be 1/5 x. So when I say j times j, quite literally I'm saying take, not g, let's take j of x and multiply it times another j of x. I'm having a lot of problems not writing that as a g, but I'm going to take 1/5 times 1/5 of x both times. So I have a fifth of the fifth is 1/25. X times x is x squared. So similar to what we had, this is more in a standard format where I have 1/5 of x squared, or 1/25 of x squared, similar to me having 1/5 of x. I could also say, if I wanted to combine these into a singular fraction, x squared over 25. Realistically though, this is probably going to be the more common of the two answers. And so what that's going to do is take us into our next set of problems. So now our next set of problems is a different type of function composition. This is where we practice function compositions by inserting one function into another. So I have my functions defined. They're slightly different than before. F is still x squared, g is now 10x, h of x is 2x minus 15, and j is 1/10 of x. Perfect. So as we jump in, if we see a function notation written like this, we have to read it from the inside out. What this is telling me is that I have x, which is plugged into g, and g, which is plugged into f. Let's highlight this in, let's do orange. Actually, no, let's just go ahead and highlight it. Okay, so I know that g of x is going to be plugged into the larger f of x. So the first thing I'm going to have to do is I'm going to go define my two functions. Let's keep it with the same color. So my f of x is equivalent to x squared, and my g of x is equivalent to 10x here. So if I want to write this, I'm going to say, okay, my f is going to have my g of x plugged into it. What is my g of x? Well, my g of x in this case is 10x. I'm going to go ahead and insert what I know g of x is. And that is going to be what I plug into f. I'm going to take that 10x and plug it into f. Okay? Well, if f of x is x squared, I'm going to take that and I'm going to say, okay, let's plug in that 10x and square it. Okay. And if I square 10x, that will get me 100x squared, which is equivalent to my starting function that I showed right here. So if I said f of g of x, it's going to be equivalent to 100x squared. Boom. And so we see that when I have a function inside of a function, first off, we'll most commonly write it with slightly larger parentheses to kind of differentiate them. But we literally just take whatever the function is equivalent of and stick it in the larger function. So think of reading it either right to left or read it from inside out. The innermost thing is the x. I plug the x into the g. I take whatever that expression is equal to and plug that into f. Let's try another one. I have h of j of x. So the first thing I'm going to do is I'm going to define my h of x just so I have it right here, which is 2x minus 15, and my j, which we are going to do that in, I think we swapped these, but oh well, 1/10 of x. So what I'm going to be doing is I'm going to be taking h, and I'm going to plug j of x into it. So what I see is I see that is going to be plugged into h. So let's rewrite this in a slightly different way to make a little more sense. If I say h, well, what are you plugging into h? I'm going to go ahead and plug a j of x in there. Okay. What is j of x, you say? Well, I'm glad you asked. J of x is 1/10 of x. That's what I'm going to be plugging into my equivalent h. Well, what was your h? We said that is 2x minus 15. So I'm going to say that's 2, whatever j of x is, minus 15. That is 1/10 of x. And there we go. So we quite literally take what we have and just plug it in. Nothing more complicated than that. Now we're going to go through and we're going to solve this to the best we can. So I know that 2 times 1/10 is 2/10, or 1/5 x minus 15. And that is going to be what our h of j of x is. And I'm going to rewrite this as h of j of x. Boom. So all that is we plug a function inside of itself. Now, again, one of the things that we mentioned is we can take a function and plug it inside of itself. There's nothing restricting us from plugging one function into another function. We can plug them into themselves as many times as we want. So first I'm going to define my f, which is x squared. So what I'm going to do is I'm going to quite literally say, I'm going to take f and plug it into itself. So my f has a little f plugged in. So if I take my f of little f plugged in, what is f? You said it's x squared. Actually, we've been writing this as an x squared. Let's plug that x squared into the x squared. But I am going to highlight this because we're doing them both in red. That is what we plugged in. My f has been replaced with x squared. I'm now going to take that x squared and stick it in to this x squared. So right here I have f of x squared is equal to this squared. Well, which x squared, you said? Well, I'm going to take this x squared and stick it into the x squared. A little confusing, I can see that, but the process works the same as if it were any other function. So I'm just going to take x squared and square it, which is going to leave me with x to the 4th, and that is the equivalent of my f of x. And there we go. Boom. And so similar to plugging a function into itself, there's no limit to how many times you can plug a function in. So for number 17, what you can see is the fact that, first off, you notice that my parentheses do get larger as we go out. So the innermost thing that I'm plugging in is going to be my f of x. I'm going to take that and I'm going to plug that into g of x. Then when I'm done, I'm going to plug that into h of x. So let's go ahead and let's define our 3 functions. I know h is 2x minus 15. See, we did g in blue, so let's say g is 10x, and f, we just got done with that one, is x squared. Okay. So the first thing that we are going to define is we are going to define this g of x. And then we're going to come back to the h. So again, I'm working my way inside out. I have the f plugged into the g. So I'm going to focus right now on what is g of f of x. Well, we know g of x is equivalent to 10x. What are we plugging into that 10x? Well, whatever f is, which is going to be x squared. So I know g of f of x means that I'm plugging in x squared into this, which is just 10x squared. Okay, I did this in black, so let's keep that color pattern going. So g of f of x is 10x squared. Now what I'm going to do is I'm going to take that and I'm going to plug that into h. So let's go ahead and let's highlight this. Pardon the helicopter flying overhead. So what I have right now is g of f of x, let's go ahead and highlight that, is the equivalent of 10x squared. So I'm going to be taking that and plugging all of that into h. So I'm going to come back around, I'm going to say, okay, this is h of this expression, g of f of x, and we know g of f of x is equivalent to 10x squared. What are we plugging that into? H is equivalent to, should have kept some space here, 2x minus 15. Okay. So if I take that, let's go ahead and separate, give ourselves some barriers right here. If I have that, h of 10x squared is going to be 2. Of that 10x squared, I'm going to plug it right in here. And just to make sure we keep things color coordinated, once we plug it in, we can see that, boom, I have now plugged that into the equation. Now the last thing to do is to simplify it. Okay. 2 times 10x squared is going to be 20x squared minus 15. I can't simplify that any further. So I know that my expression h of g of f of x is equivalent to this expression right here. Boom. We'll just work away from the inside out, or if you would rather, from the right to the left. Plug f into g. Once you're done with that, plug your answer into h. Now we could chain these up as many times as we wanted, but I think we got the idea right there. We have 2 other style questions, like number 19. Remember, we're working our way from the inside out, so when I look at this one, I see that I have 2, which I'm plugging into f, which I'm plugging into g. Now this one looks like it might be more complicated, but it's actually going to be a little easier, because as opposed to keeping this expression like we've had up here and keeping the unknown and having to plug in an unknown into an unknown, this is going to allow us to work our answers down to a single answer. So let's go ahead and let's define our 2 functions. We said g was 10x, and we know f is x squared. Cool. So what we're going to do is first I'm going to define what f of 2 is. Remember, working our way inside out. I know f of x is x squared. And so I'm saying, well, what is x? X in this case is 2. I'm going to take that 2, and I'm going to go ahead and highlight this. And I'm going to stick that into my equation. So it equals that number squared. So I'm squaring my 2. Ooh, throwing things around. Cool. So if I say 2 squared, that gives me a 4. So f of 2 is the equivalent of 4. So then I'm going to work my way out again. I know I'm taking g and plugging that value into it. F of 2 we know is equivalent to 4. So when I say g of f of 2, let's write this out. So g of f of 2 I know that's saying that's really g of 4, because I'm taking my answer right here and plugging it in. I'm going to half box that just because that is the important part. And so I'm going to say, okay, well, what is g of 4? Well, g of x is 10x, which means my g of 4 is going to have to be 10 times that 4. 10 times that 4 is just going to give me 40. So I know that my answer, g of f of 2 is equivalent to 40. There we go. So now that you've seen several of these, why don't you go ahead and try number 21, pause the video, unpause it when you're done, and see how well you did. Okay? So now that you've had a chance to try it out, we have j of negative 300. So let's go ahead and give this a shot. So j, we defined j in purple. J of x is 1/10 of x. And actually, this might be a better point to pause the video because I didn't actually have this written on the screen. So if you paused it and just kind of stared at the screen, pause it now, try it out. Okay. So if I have my j of x is 1/10 x, I'm going to have to work my way inside out. I know I'm going to have to plug in that negative 300 into my j. So let's start out with j. So I have j of x is equivalent to 1/10 x. And I'm plugging in j of negative 300 just one time. 1/10 of negative 300. And that's my first insertion. I know 1/10 of negative 300 is going to give me negative 30. So I know my initial j of negative 300 is equivalent to negative 30. That's my first hot point there. Okay. But I'm not just doing it once. I am now taking my answer, which I just had j of negative 300, and I'm plugging that into j a second time. So let's go ahead and let's redefine that. I say j of negative 300. And I'm plugging that into 1/10 of x. I know that that j is going to be a negative 30. And I'm plugging that into 1/10 of that negative 30. 1/10 of negative 30 is going to give me a negative 3. And I know that is all I'm looking at here. So j of negative 300 is equivalent to negative 3. And there we go.